Josh, fluid power industry professionals probably take pressure for granted, don't you think?
Well, if I asked someone to define pressure, they would say force over a defined area. We typically use similar units such as pounds per square inch or newtons per square meter, but pressure isn't confined for use in the fluid power industry alone. No pun intended. Pressure exists everywhere at all times, and even in the most remote location in outer space, and even a few atoms of matter loitering around will ruin a perfect vacuum.
Sure. Well, I think we all learned in school that atmospheric mass is enough to exert 14.7 pounds on every square inch plane equally in every direction.
Yes, let's think about that for a moment. If you had your hand held flat out, palm up, and we could imagine you create a vacuum under the bottom of your hand, you would have in the realm of 400 pounds pushing down your hands. Go ahead, hold out your hand.
Okay.
So, in fact, you do have 400 pounds pushing down on your hand.
Doesn't feel like it.
No, it does not at all. And give or take, based on if you have hands like a toddler or hands like a professional wrestler, you don't feel 400 pounds pushing down on your hands because that's the nature of fluid pressure as defined by Blaise Pascal. And he says when there's an increase in pressure at any point in a confined fluid, there's an equal increase at every other point in the container. So around you right now, there's 14.7 pounds per square inch on every single square inch of your body in every direction, inward and outward, on your whole body. So force from an infinite number of directions pushes equally and opposite to an infinite number of places on your body due to isotropic nature of liquid or gas.
But why, Josh? Why does the mere existence of air molecules around you cause them to push on each other in your body?
Right. There's some epic science going on here.
Okay.
So on an atomic level, we can explain the nature of pressure. You can't see air molecules around you because they are smaller than wavelength of light. So they don't bounce off of the light molecules. However, just because we can't see air molecules, it does not mean that they're not busier than a border collie with ADHD and a caffeine addiction. I'm going to refer to air molecules and atoms at this point just as particles.
Okay.
It's a lot easier to explain. So the motion of atoms in a fluid is dynamic, and it's incessant. Their motion is complex, and the particles essentially travel in a straight path until they smack into a solid object or another air molecule. After hitting something, the particles deflect, reflect, to generally bounce around like undiminishing squash balls trapped inside of a box. Their energy to create pressure, for the most part, remains constant. So energy is not wasted as heat in the Brownian chaos of particle movement. Any kinetic motive being converted to heat as a result of these smashing particles, in turn, creates an equivalent excitement in motion, conserving energy entirely.
Okay, so what you're saying is that the particle movement creates heat, and then the heat creates particle movement, both of which are maintaining that pressure?
Exactly. The pressure created from the mass of the fluid is different from the pressure created from a solid.
Okay.
So, for example, a solid object will apply pressure only in the direction of its force vector. Such as an anvil being pulled to the center of the earth, usually landing on Wile E. Coyote's head.
True.
However, if you put your finger on the side of the anvil, and only pressure is a result of the force applied by your finger, and only in the direction of the push.
Okay.
Atmospheric pressure is a result of the mass of air in a column extending up to outer space. If you placed a weightless 1-inch square tube extending way up to the troposphere, used a giant vacuum from Spaceballs and sucked out the rest of the atmosphere, you would in fact find that that tube weighed 14.7 pounds.
14.7, okay.
I find that fact amazing, especially considering the air around me provides no perceivable effect of mass on me whatsoever.
So really the pressure in a fluid power system isn't that much different from atmospheric pressure. It's just that there's a lot more of it, right?
Yes. By packing more matter into a smaller area, you're able to create more pressure. In a pneumatic system, the increase is directly proportional to the number of molecules crammed into the same size space.
Okay.
Twice the particles moving around at the same energy means twice the pressure. And a hydraulic system doesn't need nearly the same increase in particles to create exponentially more pressure. In a sealed pressure vessel measuring 0 gauge pressure, we need to pack just 1% more molecules into that space to increase gauge pressure to 2,000 psi.
Wow.
Doubling the number of particles in a hydraulic oil in this pressure vessel would result in a pressure increase over 200,000 psi on our gauge.
Great. Thanks, Josh. We learned a lot today. Appreciate it.
My pleasure.